Welcome back, students. So in this video, we're going to take some of those nebulous concepts from the previous two and put them together into a way where they're going to be a little more concrete, and you'll see how this is actually used. Through doing that, I think you're going to find this to be much more clear. Okay, let's start with this first example here. We have two measures. Each measure is designated by the line, and these two lines at the end represent it being the end of what we're doing. Okay, so you put two lines at the very end. It's like a period at the end of a sentence. So we have a time signature of 4/4. And if you remember back to the previous video, this means that there are 4 beats in a measure, and our beat is a quarter note. Okay, so if we look at this first one, we can see 1, 2, 3, 4 quarter notes in the first measure, exactly like the time signature says. Okay, now the way we're going to do this is all going to be math, fraction math. So let's write the actual fraction value below each of these. 1/4, 1/4, 1/4, and 1/4. Okay? So if we add all these together, we have 1, 2, 3, 4/4, 4/4. And what you'll see when you do all this math is that the fraction, when you add all those fractions together, you're going to get the time signature. Okay, and that's how you know that you've done things right. So let's look at this next example. First thing I'm going to point out is this here. Okay, if you imagine that this little line is separated, you can see those are 2/8 notes. But typically we just connect these two little flags together because it looks a little bit cleaner. Okay, there's actually a convention to how we do that, but you don't need to worry about that just yet. Okay, so let's look at this. We have a quarter note here, so let's write our fraction, 1/4. Then we have an eighth note, 1/8, another eighth note, another eighth, quarter, and quarter. Okay, so let's make these so they all have a common denominator by turning these into eighths. So we have 2/8, 1/8, 1/8, 2/8, and 2/8. Okay, so if we add these together, we get 2, 3, 4, 5, 6, 7, 8. 8/8, which we can indeed reduce to 4/4. We get our time signature. And that's how you know that this measure is complete. This example is a little bit more complex. You can see we have some dotted figures and some triplets here. We talked about those in the first video, so you can go back and review that if you need to. But again, it's very basic math, okay? So let's do what we've done before and add the fractional value below. Okay, so this we know is a quarter note. Now a dotted quarter note, that is worth 1.5 quarter notes, okay? So think about what is half of a quarter. That's an eighth. And another way to say an eighth, or a quarter note, is to say 2/8. So this is 1.5 2/8 notes, okay? I know that's a bit of a confusing way to say it, but we can basically write it like a quarter note plus an eighth note, okay? We could also save a step and say this is 3/8, okay? Then we have another solid eighth note. Let me put a few lines here to keep that separate. Okay, so we have another eighth note here. So 1/8, and then again 1/4. So let's add all these together. Common denominator is going to be eighth notes. So we're going to have 2 eighth notes, 3 eighth notes, 1 eighth note, and then 2 eighth notes. So 2, 3, 4, 5, 6, 7, 8. 8/8 reduces to 4/4. We know the measure is correct. Okay? Now, a triplet, if we remember, is fitting 3 of a rhythmic value into a space where 2 would usually be. Okay? So a triplet of quarter notes is going to be equal to a half note. So we can say this is 1/2, basically. And a half note is also 1/2. We can see where this is going. This is going to be 4/4. I really want to focus on this triplet here for a second. So let's say I have a triplet of eighth notes. Okay, so what is going to be going on here is that 3 of these are being stuffed into an area that would usually contain 2 of whatever is in the triplet. Okay, and in this case we have eighth notes in the triplet, and 2 eighth notes is a quarter note, so this is equal to a quarter note. So that's a little bit more complex of an example, but you can see we're still just doing fractions. All you need to know for these more complex ones like the dotted and the triplet is how to break those down. So in the case of a dot, it is 1.5 of the original value, and in the case of a triplet, you're fitting 3 of something into a space that would usually contain 2. Okay?